Last but not least, let us consider example 3, where we want to determine the voltage read by the voltmeter. To do such, we can apply mesh current analysis. Step 1 is to construct n KVL loops, where we have loop 1 that corresponds to I1 and loop 2 that corresponds to I2. Step 2 is to assign our voltage potentials consistent with our passive sign convention. That is, if we start in the bottom left-hand corner, as we move through loop 1, we assign V1 to our 6 ohm resistor, and then as we progress through the upper portion of the loop, we'll assign V2 to our 3 ohm resistor. Then we proceed down and back to our starting location. For loop 2, we start in the bottom left-hand corner, proceed upward until we encounter our 3 ohm resistor, where we already have a polarity associated with it, such that we do not redefine it. And then we move down to our 6 ohm resistor, where then we apply V3 across said resistor, and then back to where we started. Step 3 is to construct n KVL equations. That is, we are going to need 2 KVL equations for our system. In doing such, for our mesh current 1, we can have the following. Minus 12 volts plus V1 plus V2 minus 8 volts is equal to 0. Or we can say V1 plus V2 is equal to 20 volts. For mesh current 2, we know we'd have plus 8 volts minus V2 plus V3 is equal to 0. Or we could say V3 minus V2 is equal to minus 8 volts. Step 4 is to apply Ohm's law to express our voltage potentials in terms of our mesh currents and our resistances. That is, for mesh current 1, where we had V1 plus V2 is equal to 20 volts, V1 can be expressed as I1 times 6 ohms, and then V2, recall that we'd have a current I running through our 3 ohm resistor, which is the difference of I1 and I2. V2 is then expressed as I1 minus I2, said quantity times 3 ohms, and this is equal to 20 volts. For mesh current 2, we'd recall we already have minus V2, where V2 is expressed for mesh current 1, plus V3, where all we have is I2 running through our 6 ohm resistor. That is V3, which is expressed as I2 times 6 ohms, less V2, which is expressed as I1 minus I2, quantity times 3 ohms is equal to minus 8 volts. Therefore, we can construct a system of equations. We'd have 9I1 minus 3I2 is equal to 20. For mesh current 1, we'd have minus 3I1 plus 9I2 is equal to minus 8 for mesh current 2. Solving for I1 and I2, we have I1 is equal to 2.16 repeating amps, and I2 is equal to minus 0.16 repeating amps. Thus, we can determine our voltage drop measured by the voltmeter, where V3 is equal to I2 times 6 ohms, or minus 1 volt.